All right, let's talk some more about circles and tangents. So what we've learned so far is we know a tangent is a line that intersects exactly one point on the circle. And we've also learned that I'm not very good at drawing these, so bear with me for just a moment. So there we have a tangent. And we know it intersects exactly one point on the circle. Here we have a radius, which we know goes from a point on the circle to the center point, in this case, point P. And we also know that we measure from a line to a circle on a perpendicular, because it's the only way to get consistent measurements. So for a line to be tangent to a circle, it is tangent to a circle if and only if the line is perpendicular to the radius of a circle at its endpoint on the circle. So much like I have drawn here. So how is this useful to us? Well, let's take a look. So if we have a line here and a radius here, and let's go back to blue for this one. And another line here. And let's label our points. Call this one S and call this one T. And we're curious. Is the measure of angle T equal 90 degrees? Or is line ST tangent to circle P? Well, we would have to measure these and find out that this measures 12, this measures 37, and this measures 35. Let's make it room. So how could we possibly know if it's a tangent? Well, we know the Pythagorean theorem. A squared plus B squared equals C squared. So if 35 squared plus 12 squared equals 37 squared, then ST is a tangent. If it's not equal, then it is not a tangent. So let's do the math. 35 squared is 1,225, and 12 squared is 144. 37 squared is 1369, and 1225 plus 144 is a little bit more room, 1369, which does in fact equal 1369. So ST is a tangent. Let's look and see another way we can use it. Here we can use our tangent to find the radius of the circle. Let's go to green for this one. Because we know that AC squared equals AB squared plus CB squared. Right, because here we have to have our right angle, So AC has to be the hypotenuse. Well, in this case, our hypotenuse is 50 plus r. 50 plus r squared equals 80 squared plus r squared. And we can go through and we do the FOIL method, and we end up with r squared plus 100r plus 2500 equals 6400 plus r squared. Then we subtract r squared from both sides, cancels those. We're going to subtract 2500 from both sides, which leaves us with 100r equals 3900, or r equals 39. Come back up here and we find out the radius of our circle is 39. All right, so sometimes, let's do pink. We have two tangents and they come from a common point external to the circle. And in that case, what we're going to find is that these two segments are congruent. So how does that help us? So if we know that this is 28 and this is 3x plus 4, well, 28 equals 3x plus 4. Then we go through our algebra, and 24 equals 3x, and x equals 8. So we can find x that way. What else do we know? Well, we know that from point C to point T, because we know this is a tangent, that's going to be right angle. And from point C to point S is also going to be a right angle. So we have a lot of different tools to use when dealing with tangents. Because we know if we have a tangent, if it is a tangent, it's perpendicular to the radius that ends at that point. And if two tangents meet at a common external point, they're going to be congruent.